What if I told you that Archimedes solved calculus problems 2,000 years before Newton was even born? Today, we're diving into one of the most ingenious mathematical discoveries of all time, the method of exhaustion. Picture this, it's 250 BC. No algebra, no coordinate systems, no calculus as we know it. Yet Archimedes of Syracuse was already calculating areas under curves with stunning precision. While Newton and Leibniz get all the credit for inventing calculus, Archimedes was essentially doing integral calculus using nothing but pure geometric reasoning. Let's look at the specific problem Archimedes tackled. We have what's called a parabolic segment, the region bounded by a parabola and a straight line. If we place a point at distance x from the origin, the vertical distance to the curve is x squared. When the base has length b, the height of our figure is b squared. The question is, what's the area of this curved region? Where's where Archimedes' genius kicks in? He developed what we now call the method of exhaustion. The idea is brilliant in its simplicity. First, divide the base into equal parts. Then, build rectangles from below. These give us an underestimate of the area. Next, build rectangles from above. These give us an overestimate. As we add more and more rectangles, we exhaust the difference between these bounds, trapping the true area between them. Watch what happens as we increase the number of rectangles. The green rectangles from below creep closer to the curve, while the red rectangles from above squeeze down. The true area is trapped between these bounds, and as we make our rectangles thinner and thinner, both approximations converge to the same value. Asterisk. Now here comes the absolutely mind-blowing part. After working through all the geometric reasoning, Archimedes discovered that the area of the parabolic segment is exactly 1/3 the area of the surrounding rectangle. That's right, a equals b cubed divided by 3. This is the exact same answer we get today using integral calculus, but Archimedes got there using only geometric arguments. What Archimedes was essentially doing was computing what we now write as the integral of x squared. From 0 to b, his method of exhaustion was a precursor to the limit processes that define modern integration. Same mathematical truth, just expressed in different languages separated by 2 millennia. This isn't just a cool historical footnote. Archimedes' work laid the groundwork for what would eventually become integral calculus. Cavalieri, Torricelli, Fermat, and Pascal all built upon these ideas in the 16th century. Newton and Leibniz refined them in the 17th century. And mathematicians like Cauchy and Riemann put the whole theory on solid foundations in the 19th century. The next time someone tells you that calculus is just about memorizing formulas, remember Archimedes? He showed us that mathematics is about insight, creativity, and seeing connections that span centuries. If this blew your mind like it did mine, smash that like button. Subscribe to MathVare for more mind-bending mathematical discoveries. And hit the notification bell so you never miss our latest videos. What other ancient mathematical mysteries would you like us to explore? Let me know in the comments below. Thanks for joining me on this mathematical journey. Remember, at MathVare, we believe that's where mathematics meets wonder. Till next time, keep questioning, keep learning, and keep being amazed by the beauty of mathematics.